Hi boys and girls, so today we are going to solve some word problems using Newman's analysis. We've already had lots of practice with this, so let's get started. I've already written 2 worded problems here, so let's start with the first one. If you had 89 jelly beans and you ate 24 of them, how many would you have left? So our first step is to underline the key words and numbers. So the key numbers here would be 89 and 24. The second step is to circle the question words. So this word here, 8, you ate 24 of them. That means you're subtracting 24 from your collection. So I'm going to circle that as a question word. Some more question words I can see is how many would you have left? Have left means you need to find the remainder. So this is going to be a subtraction word problem. Our third step is how you're going to work out your answer. I'm going to put it in an algorithm. So 89 minus 24 equals, let's start with our ones first. 9 minus 4 equals 5, that's correct. 8 minus 2 equals 6. Okay, so this is our answer, but before you put that answer into a worded format, we need to check if that's correct using its inverse. So the inverse of subtraction is addition, but I'm going to put it in a longer format just to see how we can quickly swap it around to make it an inverse. So I'm going to put the 65 at the beginning of our equation. So 65 plus the 24 drops down equals 89, and that does equal 89. If you need to use your calculator to check the answer, that is fine, but as long as you've done these 2 steps and then found its inverse, then that's fine. Oh, sorry. Our next step, as long as you have this right, 65, and you've checked it with both, and they both fit in there perfectly, then that is correct. That's your answer. So we're going to put it in a sentence format now. How many would you have left? Oh, am I right? I would have 65 jelly beans left. Okay, so that's our 3 steps for today. We need to do this, write the algorithm, and then put it in an extended form, use its inverse, and then put it in a sentence format. So I'm going to delete these just so we can see the next question. Okay, so Susan scooped 24 scoops of ice cream evenly into 6 cones. How many scoops of ice cream are on each cone? So our first step is to underline the key words and numbers. So 24 is a key number. We're going to need that. And 6 is a key number too. Now we need to circle the question words. So I can see here, how many scoops of ice cream are on each cone? On each cone, that's asking us to count how many scoops of ice cream are in each collection. Okay, so let's put this in an algorithm. So 24 divided by 6 equals, now I'm using the slash button because I don't have a division button on my keyboard. So that means divide. Okay, so 24 divided by 6. So sometimes this might be a bit tricky, but if you use the inverse, this might help you. So we're going to put it in its inverse, sorry. So something times, we're dropping the 6 down, is equal to 24. So you can use your 6 times tables to figure out this answer. So something times 6 equals 24. 6, 12, 18, 24. So 4 times 6 equals 24. So 4 must be our answer up here. 24 divided by 6 must equal 4. And don't forget to check on your calculator if you need to check it. Okay, so that's our answer 4. Let's put it in a sentence format. How many scoops of ice cream are there on each cone? There is 4 scoops of ice cream on each cone. Alright, so as long as you have your working out in your book, you can write this sentence on your PowerPoint slides, okay? So we only need this sentence, but you need to work out the algorithm and its inverse on your book, on your whiteboard or in your books, okay? So good luck. The next page has a few different worded problems for you to answer.